Hello everyone, welcome to our podcast on our YouTube channel Green Gym Talks. My name is Deepak and here is my partner Shruti. Today we are exploring a fascinating topic from the world of food science, that is somatic hybridization versus conventional hybridization, a comparative balance.
Hi everyone, today we will discuss in this topic that what these two methods are, what are their strengths, what are their limitations and what is the basic difference between them. At the end of this podcast, you will get to know that what it contributes to food crops.
Before diving deep into the topic, let's quickly recall what is hybridization. It means crossing two genetically different parents to create a offspring with desirable traits from both the parents.
Exactly. In food crops, hybridization plays a very important role. Hybridization combines the traits like disease resistance, stress tolerance and depends upon the fruit quality, and all of it combines to a better, good, superior cultivar.
Let's start with conventional hybridization, the classical or sexual hybridization method. In this, gametes from both the parents are fused through pollination and fertilization. The resulting zygote develops into a hybrid plant.
Yes, people, exactly. This technique has evolved from the centuries in the plant kingdom. It depends upon the sexual compatibility. That means two parents must belong to the same species or closely related species.
Okay, are you aware of any of the example of it?
No.
Okay, let me tell you. There are many successful hybrids in many of the fruit crops. Like in mango, we have a hybrid named Malika, the cross between Neelam and Dasheri. Neelam being a female parent and Dasheri being the male parents. And in other fruit crops like blueberries, there is a cross between Tif Blue and Mentito.
Okay, but everything has its own limitations and its strength, and in this the limitation is that conventional hybridization can't overcome the natural crossing barriers between the distantly different species. So if plants can't sexually reproduce, then we can't make hybrids.
Right, Shruti. That's why modern biotechnological tool comes into the play, and tool is somatic hybridization. Are you aware about it?
Yes, instead of gametes, we use somatic cells or protoplasts and fuse them artificially in the lab by the method PEG, polyethylene glycol mediated fusion or electrofusion.
Right. The fused protoplast then resolved into the hybrid plant that carry genes from both the parents, even if they are sexually incompatible.
This technique is extremely useful in some fruit crops like citrus, because in citrus there is a highly and very big problem like sexual incompatibility and nuclear embryony, which makes it difficult to produce the hybrids.
Okay, but are you aware about any of the example of it?
No, not sure.
Okay, let me tell you. There is one of the famous citrus somatic hybrid that is cross between sweet orange and trifoliate orange that has the traits for cold tolerance and its fruit quality traits.
Okay, Deepak, let's differentiate the both sides. And let me start with the conventional hybridization. In conventional hybridization, it's the fusion of gametes.
But in somatic hybridization, there is the fusion of somatic cells, usually protoplasts.
In conventional hybridization, it requires a sexual compatibility.
But somatic hybridization works across all the sexual barriers.
In aspect of genetic recombination, conventional hybridization is natural and through meiosis.
But in somatic hybridization, it is artificial through protoplast fusion.
In conventional hybridization, the time period is very long in case of fruiting and flowering.
But in somatic hybridization, it is a faster process as compared to the conventional hybridization.
In conventional hybridization, the genetic control is less precise.
But in somatic, we have more control over the parental contribution.
And the conventional hybridization is widely used in the food crops.
But somatic hybridization is still limited to some of the fruit crops only, as research is still going on.
That's the great comparison, Deepak. Basically, conventional hybridization is natural and reliable,
while somatic hybridization allows us to cross the species that would never maintain nature. Let's highlight the strengths of each method.
So let's start with conventional hybridization. It is easy, low cost and need less lab facilities. Number second, in this natural recombination leads to stable and viable hybrids. And the last point, it is beneficial for fruit crops and compatible fruit crops such as guava, mango and papaya.
So now let me tell you the strengths of somatic hybridization. First, it overcomes the sexual incompatibility barriers. Second, it allows the transfer of cytoplasmic traits like innate sterility or disease resistance. Third, it is also useful for introgressing traits like disease resistance, cold hardiness. And the last point is, it speeds up the breeding for all the perennial fruit.
So let's talk about the limitations of conventional hybridization and somatic hybridization. First of all, conventional hybridization. It is restricted to some sexually compatible species. And the second point is long juvenile phase in fruit crops delay the selection. And the third point is many hybrids show the undesirable traits and the sterility. And the last point is controlled pollination is labor intensive. Now Deepak, please tell us about the limitation of somatic hybridization.
So the limitations of somatic hybridizations are: first, it requires advanced lab facilities and trained personnel. Second, low efficiency of protoplast fusion and regeneration. Third, somatic variation may also cause genetic instability. And the last point is regulatory and field performance challenges still exist.
Okay Deepak, so we have talked a lot about both the hybridization, conventional and somatic hybridization, its strength and its limitation.
But Shruti, do you know any real world applications of conventional and somatic hybridization?
Yes, there are some successful somatic hybrids in fruit crops like in apple, citrus and grape. In citrus, it's sweet orange and trifoliate orange, that is cold tolerance. And the second apple, it's apple plus crab apple as hardiness improvement. In grapes, it's Vitis vinifera and Vitis rotundifolia as hardiness improvement. And of course, conventional hybrids are the backbone of the breeding program. For example, Malika mango, Arka Aruna Gava and Prabhani Sund grape.
That's great. You have a good knowledge about the real world applications of both these hybridization methods. So now let's wrap up this podcast. Both conventional and somatic hybridization have their unique roles. Conventional hybridization is time tested and natural, while somatic hybridization creates new genetic possibilities beyond sexual barriers. So anything you want to add?
Yes, Deepak, your points are absolutely right. I want to add that the future lies in integrating both of these as conventional and somatic hybridization. For example, molecular marker, genetic engineering and along with conventional hybridization, all that include in crop improvement and good fruit yield and food quality.
So thank you guys for listening to our informative podcast. I hope you loved the content and thank you everyone.
And we hope it was informative. Just stay updated and thank you, and subscribe our channel, that is Green Jane Vlogs. Thank you.
Bye.